Might you at any point trust it? Picture a heavenly event so huge that it creates shadows on Earth apparent even without trying to hide. That is the scene we may be on the verge of seeing in the Orion constellation. The star Betelgeuse is acting strangely, indicating a looming cosmic explosion that will illuminate our sky more than ever. However, when will Betelgeuse go supernova, and what will it look like? According to researchers, what secrets could this heavenly event uncover? Join us as we plunge deep into the details of what's actually going on with Betelgeuse and the effect it could have on Earth and maybe the whole nearby planetary system. Found around 650 light-years from Earth in the Orion constellation, Betelgeuse isn't just any normal star. It's a red supergiant, quite possibly one of the most glowing stars known to us, shining with a brilliance over 100,000 times that of our Sun. Well, Betelgeuse stands out not just for its brilliance, but also for its history and importance in human culture. Named after the Arabic expression Yad al-Jawza, which means the hand of Orion, Betelgeuse has been noticed and documented by ancient civilizations for hundreds of years. It has served as a guide for travelers and a mark of wonder for astronomers, with its ruddy shade distinguishing it from other stars in Orion. To give some perspective on the sheer immensity of Betelgeuse, if it replaced our Sun, its edges would extend all the way to Jupiter. How could a single star achieve such huge proportions? At 10 million years old, it's significantly younger than our 5-billion-year-old Sunday. However, Betelgeuse's enormous size means it burns through its material much faster, predicting a shorter life expectancy than that of other stars. Now this celestial behemoth, traversing a volume big enough to contain more than 1 billion of our suns, is approaching its final cycle. When stars of such size reach their twilight years, they don't just disappear, they exit with an extravagant flare. A cosmic explosion blast beyond human understanding in terms of energy and brilliance. Such an event has the potential to dominate a whole galaxy, creating patches of brilliance across vast distances. The last time Earth saw a supernova blast this close was in 1604, before the development of modern telescopes. This event, known as the Kepler supernova, was the last supernova to be seen in our Milky Way galaxy with the naked eye. It remained visible for more than a year and a half, more brilliant than any other star in the night sky, and even visible during the day for several weeks. Ancient records from various civilizations, including Chinese and European astronomers, recorded the appearance of this new star. Interestingly, remnants of this blast, in the form of an expanding debris cloud, can still be observed today with modern telescopes, giving us insight into the violent ends of massive stars. Supernovae have been rare for observers on Earth, but imagine for a second a stellar explosion so intense that it rivals the brilliance of a full moon, casting shadows at night and even visible during daylight. The radiation from such an event could charge our atmosphere, possibly affecting satellite operations and even the climate. Betelgeuse, with its erratic dimming patterns, suggests it may be preparing for just such a grand display. Just recently, astronomers made a surprising discovery. Between October 2019 and mid-2023, Betelgeuse underwent a remarkable transformation that drew the attention of astronomers and skywatchers worldwide. Known as the Great Dimming, the star's brilliance, which had been stable for centuries, began to decline significantly. This sudden change was so noticeable that even casual stargazers saw it when comparing Betelgeuse to other stars in Orion. This means that we may not be hundreds of years away from seeing its supernova blast, but maybe only a few decades or even less. By April 2023, cosmic observations reported that Betelgeuse had returned to its normal brightness levels, leading many to believe that the period of anomaly had ended. In a stunning twist, the following months saw Betelgeuse's brightness intensifying by an astounding 50%. Such prominent variances, while typical of variable stars, were surprising for a star like Betelgeuse, which had mostly shown predictable luminosity cycles. The sudden and extreme surge in its brilliance pushed the star back into the spotlight, igniting discussions about its future. Stars are not just shimmering points of light, they are dynamic entities with life cycles, behaviors, and mysteries of their own. For some celestial bodies, periodic brightness variations can be expected, akin to the rhythm of Earth's seasons. Throughout its stellar lifetime, Betelgeuse has kept a relatively consistent 400-day brightness cycle. However, with the Great Dimming, it appeared to defy its established behavior, testing our understanding of cosmic phenomena. While the exact reasons behind Betelgeuse's abnormalities are still under investigation, a compelling hypothesis has emerged. This hypothesis, focusing on stellar activity and mass ejection, presents an intriguing scenario. Picture Betelgeuse as a massive celestial volcano quietly ejecting and expelling vast amounts of its material into space. Recent observations from the Hubble Space Telescope revealed that Betelgeuse had recently expelled a tremendous amount of surface material into the universe. This ejection, a monumental event, was 400 billion times the mass typically released during similar solar phenomena, equivalent to several times the mass of our Moon. Such events can result in the formation of a thick dust cloud around the star, affecting its apparent brightness and temporarily making it more challenging to observe. Then, as this dust began to scatter or was driven away by the star's radiation pressure, the veil lifted. This could explain its subsequent return to normal brightness levels. One way or another, these new events suggest a star that's far from done astonishing us. Many speculate that Betelgeuse may be approaching the twilight of its life with a supernova event, a sudden burst of energy that can eclipse an entire galaxy on the horizon. This phenomenon occurs when there is a sudden change in the star's core. Such changes can arise if a star absorbs too much matter from a neighboring star, or in Betelgeuse's case, from the exhaustion of its nuclear fuel, which overflows its mass into the core, setting the stage for a catastrophic collapse. Born from the gravitational collapse of gas within molecular clouds, stars like Betelgeuse begin their journey by consuming hydrogen in their cores. This initial phase, known as the main sequence, lasts for billions of years and forms the foundation of a star's life. As stars near the end of their hydrogen supply, they expand, adopting new energy sources. In the case of Betelgeuse, as hydrogen depletes, it begins to burn helium, leading to the formation of carbon and oxygen. This transition from the main sequence to the helium-burning phase is marked by the star's evolution into a red giant. Over time, as helium reserves decrease, the star undergoes further expansion and shifts into other burning stages, each marked by the fusion of progressively heavier elements. The larger the star, the faster these transitions occur, given the immense gravitational forces at play. Unlike lighter elements, iron doesn't release energy when fused. So the energy produced is insufficient to counteract the star's own crushing gravity. The star inflates in size, eventually collapsing and triggering a massive rebound explosion, resulting in the explosive force of a supernova. So is Betelgeuse nearing the edge of a catastrophic end, or simply biding its time? Ongoing research by Japan's Tohoku University suggests that the star may currently be in its carbon-burning stage. Lead scientist Hideyuki Umeda believes the core could collapse within a few years once its carbon reserves are exhausted. But not all researchers agree. Studies from Hungary's Konkoly Observatory hypothesize that Betelgeuse is still in its earlier helium-burning stage. The one thing all scientists seem to agree on despite these debates is that Betelgeuse is set to become the Milky Way's next supernova, but pinning down the timing of this event remains a vast guessing game, with estimates ranging from just a few years to 100,000 years. Amid these scientific discussions, one fact remains unchallenged: the very nature of our observations. When we look up at the starry sky, there's a subtle paradox we often overlook. This paradox lies in the concept of time and light in our vast universe. Stars and celestial bodies are so distant that their light takes an immense amount of time to reach our eyes. For example, light travels at 186,282 miles per second. Still, it takes time to traverse the vastness of space. Looking at Betelgeuse, you're actually seeing a spectacle from 650 years in the past. To put that in context, when this light left on its journey toward Earth, the Renaissance was just unfolding and adventurers like Marco Polo were making their mark on history. Every observation we make of Betelgeuse is like looking through a vast time capsule, giving us glimpses into its distant past. If, for instance, Betelgeuse had already exploded in a brilliant supernova, we wouldn't know for another 650 years. So while we study and predict its impending supernova somewhere out in the vast universe, this amazing event may have already unfolded. We're simply waiting for its light to reach our eager telescopes.